Hi, welcome to the tutorial Correlation. By the end of this topic, you will be able to explain correlation and its significance, calculate correlation between two variables, and arrive at cross-correlation matrix among multiple numerical variables using Python. Let's answer the next two questions now. For that, we need to understand what correlation is. Correlation is a measure of dependence or association between two variables. That is, how does one variable change with the change in the other? Most often, it refers to how close two variables are to have a linear relationship with each other. The correlation between two variables can be positive, negative, or zero. A positive correlation means that if one variable increases, the other increases too, while a negative correlation means that with increase in value of one variable, other variable decreases, while a zero correlation means that changes in one variable with respect to the other variable are random and there is no pattern. So far, we have been visualizing correlation between two variables using scatter plot. As you may recall the scatter plot between flat area and sale price. Mathematically, correlation is represented by correlation coefficient, usually denoted as R. Now we need not get into the formula used to calculate correlation, but it is sufficient to know that it can take any value between -1 to +1, where a positive value represents a positive correlation and a negative value represents a negative correlation, and also the value 0 represents no correlation at all as shown in the chart given on the screen. Higher the absolute value, stronger the relationship, and if the value is closer to 0 on either side, then weaker the relationship. In Python, the correlation is represented by cor. The code is very simple and we need not use any library for this. First, we write the variable 1 followed by cor and in brackets the next variable, and the code will look like as shown on the screen. Press Ctrl and enter and we have the correlation values. The correlation is coming out to be 0.695, which we can say is a strong relationship as we have already seen in the scatter plot. There is another way for finding out the correlation, and that is using the NumPy library. Here also we get the same values, and only difference is we get the result in a matrix format. So let's write the code and execute it. As we discussed earlier, we get a matrix output using the NumPy library, which is also useful. Now let's see how other independent numerical variables are correlated with the target variable. For that, we can either calculate the correlation one by one as we did earlier, or we can write the code as shown on the screen and get the correlation among multiple variables. Great, we have obtained the correlation matrix of the selected independent variables. Since this is cross correlation, all the diagonal values will be 1 because correlation of a variable with itself will always be 1. For now, let's focus on sale prices correlation with other independent variables. Now as you can see, variables flat area, living area, overall grade have good positive correlation with sale price, and age of house has a weak negative correlation, while years since renovation has a weak positive correlation. We usually select only those variables for building the model which have high correlation with the target variable. That may be negative or positive. And we would learn more about this when we study the concept of variable selection in the 5th module. Now as the name suggests, here we look at correlation among independent variables themselves. For example, if we want to see if there is any relationship between the flat area and the age of the house, or say between the number of floors and the number of bathrooms, and so on. We have already got the cross correlation metric among all the numerical variables, and we can use that to study one independent variable correlation with another. Let's focus on the variable flat area, which is in square feet, as this is the variable which we are exploring now. From the matrix, that is cross correlation of flat area with the rest of the 14 independent variables, we find 5 variables which have strong correlation with this variable. These are number of bedrooms, number of bathrooms, overall grade, area of house, living area. So as we increase the flat area, these variables will also increase. By strong correlation, we mean the correlation score is more than approximately 0.55. Now, you must be wondering, why are we interested in correlation among independent variables? How does that matter? Often, if two independent variables that are highly correlated with each other are also correlated with the dependent variable, then using both independent variables in the model may result in a suboptimal or poorly understood model. Since the model will most likely use only one of those two variables in the equation and may give other variable as statistically insignificant variable, since whatever predictive power this second variable had to explain the variation in the target variable has already been explained by the first variable, and hence the second variable does not add any incremental value to the accuracy of the model. While this in itself may not be a problem, however, as a data scientist, you would want to be sure that between the two variables, the model is choosing the correct variable, since the implication of picking the wrong variable can be significant. For example, in our house price prediction model, right now number of bedrooms and flat area may be highly correlated, and our model may choose the number of bedrooms as better predictor, while in reality, we know that the flat area is what should determine the prices. If we were to use this model on a dataset which had lots of houses with high number of small bedrooms but less flat area, the model would predict high sales prices for these houses too, which would be inaccurate since it missed the actual driver of the house price, that is flat area. Which is why, while selecting input variables for the model, we look at correlation between independent variables, and if two independent variables have high correlation with each other above a certain value, then we should make a conscious choice of which one to keep in the model. We will cover this in detail when we talk about variable selection in greater detail in Module 5. So this completes our exploration of numerical variable. In the next tutorial, we would be learning to explore categorical variables.